So this is Investigating Friction with Lily Bacon, Corey Grassmyer, and Ethan Stav. Our main goal for this experiment was to understand how mass affects the force of friction on an object that has a constant force being applied to it. We tried to answer the question, how does increasing the mass of an object affect the frictional force? There are a multitude of constants that we use in order to isolate the relationship. The first being the force on the cart, which we used by using a set weight on our pulley, the friction coefficient, which we isolated using the same table and the same surface, the starting velocity, which we isolated by just starting at 0, and from this experiment we tried to establish that as the total mass of the cart increases, the amount of frictional force should increase. Our experimental design used an IO lab, a pulley, string, and weights. We attached the string to an IO lab, hung that string over a pulley over the side of the table, attached a 100-gram weight to it, and then dropped the weight, and tracked the acceleration of the cart of the IO lab and the force felt on the IO lab. Then we added more weights and added weights to the IO lab and repeated the trial. Our null hypothesis is that there wouldn't be a difference between the frictional force between our trials. Here you can see the trial 1 where we had no additional weight on the IO lab, and trial 3 where we had 150 grams of weight added to the top of the IO lab.
Okay, so in order to find the numbers that we used, we calculated the force within the system by multiplying the mass times the acceleration. And then we used this for the equation F equals un, as we calculated n equals mass times gravity. And so when we plug in F equals un, we can find the friction coefficient. And then we found for trial 1, the friction coefficient was negative 0.583. And for trial 3, the coefficient was negative 0.22. And this shows that as we added weight to the IO lab, that the frictional coefficient decreased. Our experimental results, we found that U is the friction coefficient. This is the force between the two objects as one of them moves. This was shown as the IO lab moved on the table. N is the net force on the object. This can be found by multiplying the mass times the gravity. And as you increase the mass of an object over time, ideally the overall force, which will increase the overall force, F equals un. We failed to reject our null hypothesis because the friction force was not larger when we added more weight. It decreased instead. This could be due to some of the limitations, which would be the length of each trial was not long enough to achieve solid results, and we only tested 2 other weights added to the IO lab, and this may not have been enough trials to prove the results to be significant, as well as human error, which could have also caused a variety between the trials. In conclusion, we found that as we increased the weight of the frictional force was not larger. We think this was due to a mistake in our lab setup. The friction coefficient in theory should not change, it should stay the same. And since we kept the force that was applied on the IO lab by using gravity, and we were able to isolate the frictional force.